Good morning, everyone. How are you all? Okay, very good. So listen here, everyone. Today we'll understand one new topic: inclined plane. What will understand? Inclined plane. We'll understand what is this inclined plane, and that surface is smooth or rough. If it is smooth or rough, how motion of an object is happening? What is the acceleration? That everything we'll try to understand. So please, everyone, write here heading. Right? Inclined plane. Right heading inclined plane. So do a picture like this. So this is the picture of an inclined plane. Okay, all of you listen. One plane is inclined here, and one mass is here. One mass is there, M. And let me take the surface. Is a rough surface. Okay, the surface. Let me take it is a rough surface. Rough surface. Some US is there. Friction is there. And here to here angle. Let me take theta. Mass M is there. Angle theta. You want to height, you want to take this height also, you can take h, height of the inclined plane. But here remember one mass is there. Now suppose I am telling this mass is here. Okay. Now rough surface is there. Inclined plane. This is the what inclined plane is there. One plane is inclined. So it's making certain angle with the horizontal. Okay. Like this also you can represent. Sometimes you can represent like this also, notice. This also one inclined plane you can take. And this angle you can take as a theta. This theta what you call basically? Now theta you call basically what? This is one inclined plane. This also inclined plane you can take. This theta is called basically what? Angle of inclination. What? Angle of inclination. Theta is angle of inclination. Okay. Like this also you can do picture, like this you can do picture. This mass can be here also, one mass can be here. This it can slide like this. Anything can be. So this one, this triangular shape, whatever they are telling, that is called basically inclined plane. Okay. Now what will understand? Now here, this picture will consider. Okay, you understood what is inclined plane? What is that theta? So here what I will consider? I will consider here. Let me write this theta what? Theta is basically angle of inclination. This left side picture alone I will take. Left side picture alone I will take. Theta is angle of inclination. And what is mu s? What is mu s? Coefficient of static friction. Static friction. Now next what we'll do? We'll try to understand this free body diagram of this block. Free body of, this is the block here, the block. And as we told, this one is inclined plane. This is the inclined plane. If I'll do free body diagram of a block M. So what I'll get here, all of you listen. In this axis they are here, mass is there. So like that you keep like this dotted line. Keep this mass here, mass M. And this is the angle theta. You keep this angle theta, notice. This angle is theta. Listen, here take one horizontal axis, one vertical axis. In white color I am taking one horizontal axis, one vertical axis here. Okay. So here this is your vertical axis, and here it is horizontal axis. So white color I did one vertical axis along this direction vertical axis, along this direction horizontal axis. So vertical and horizontal two direction I did. I can consider it is y axis, like this is your y axis. This is your what axis? X axis. X prime, y prime. Now why I am considering this? Because you know already when you want to find free body diagram or you are doing free body diagram, you want to understand the motion of this object. how the object is moving, how the object is moving. Okay, how the object is moving, that one you want to understand. Okay, what is the acceleration of this object you want to understand, you want to find what is the acceleration here. Okay, we have considered already it is a rough surface, means friction will come into exist. Okay, so that things and all you want to understand. Now after doing x-axis, y-axis, what you do here, now all of you listen carefully. Here you take some components, force, whatever force acting on that, you try to understand that. Suppose I am taking this force first, this force. First here on this mass vertically downward, which force will act vertically downward? Gravitational force, so mg. And if this angle is theta, automatically you can check this angle with this line, with this white color dotted line is there, that is which your vertical axis, y axis. With that another angle will come, now this angle will become theta. If that angle theta, then weight will have two component here. What component? In this direction you will have mg cos theta. Okay, and as here inclined plane is there, inclined plane will be giving one outward normal, right? Yes or no? Outward normal will be there. Let me take like this, outward normal here. Outward normal is n. Outer normal is n. And here this is mg cos theta. In this direction what? In this direction will be mg sin theta. Now mg is having two component. One is mg cos theta, mg sin theta. Check here. This is the theta connected axis. So mg will have one cos theta and another to the x axis. It will have mg sin theta. And inclined plane is pushing that mass with normal direction n. And as you told, it's a rough surface, so friction will come into exist. So your frictional force I can give like this. This is your F, frictional force. Okay, your frictional force is acting parallel to the contact surface. So this many forces are acting on this object. One is mg. Mg has two components. One is mg cos theta, mg sin theta. And from the geometry you can check here, this geometry you can say this theta both are equal only. Mg and vertical axis theta both are same. That's why mg will have one cos theta component, one sin theta component. And friction will be there, which is opposite to the motion. Actually, object may move in this direction. Okay, object may move in this direction. So let's take acceleration in this direction. So acceleration of this object, let's consider in this direction with a. So friction will act opposite to the acceleration. Yes or no? Clear. Now here what will do? Friction will oppose the relative motion. Now here we want to find this acceleration. What is the acceleration here? We want to calculate that acceleration. Okay. Now what we can do here? You apply Newton's second law. Applying Newton's second law here. Applying Newton's second law. Applying Newton's second law, what I can get? Now in y-axis you apply. In y-axis what you are getting, say? In y-axis, see y-axis there will be no motion. In y-axis there is no motion. If there is no motion, so what I can write? Now n equal to what? N equal to mg cos theta. Normal reaction will be equal to the component of the weight. So n will be, this upward force will be equal to downward force. As y-axis no motion. Now in x-axis if we will try to see, everyone check in x-axis what is happening. X-axis what is happening, check. See here, object is moving. Suppose I consider motion is downward direction, then acceleration a is downward in the direction of mg sin theta. That means your mg sin theta is greater. So I can write mg sin theta minus frictional value. Mg sin theta minus friction equal to what basically? Mass times acceleration. So this is what is getting in x-axis. See, x-axis two forces are there. Mg sin theta F. Motion I considered in mg sin theta direction. So mg sin theta minus F you have to do. And as normal you know, F equal to nothing but what it is? F equal to mu times n. Okay. F equal to friction value or a maximum value of static friction is nothing but that is basically what? Mu times n, mu times n. Now here it is mu s or mu basically you can write. Okay, you can write mu also no worries. You can keep here mu is the static friction value. Okay. Now I can write here what? Mu into mg sin theta, mg cos theta. N value is mg cos theta. So friction value I can get this much. Friction value I can get mg mu mg cos theta. Yes or no? Okay. This friction you can take as a static friction, no worries. Static friction you can take. Mu s. You taken already written here. You write. You want to keep, you keep, no worries. Mu s mg cos theta. Okay. Now all of you listen. What happened here? Now y-axis, x-axis, force equation you wrote, and also you wrote what is friction value. Now if this friction value I will substitute in this equation, x-axis equation, then I will get acceleration. Okay. Now let's substitute and get. So this is your equation 1. This is your equation 2. Let's take equation 2. Now substitute the value of f in equation 2. Substitute the value of equation 2. Value of f in equation 2. Now let's write here. Just wait 1 minute. So right here, substitute the value of f in equation 2. So what I'll do here, everyone check, mg sin theta minus f equal to mass times acceleration. This was the x-axis equation. All of you listen carefully here. In x-axis, your mg sin theta 1 force, f 1 force. Acceleration is vertically downward in this direction, x-axis. Not vertically exactly, x-axis, slanted direction. So mg sin theta is greater. So mg sin theta minus f equal to ma you got. Now this f value substitute there and check what is coming. Now f value will substitute here. Let's see, mg sin theta minus mu s mg cos theta equal to ma. Now check here, m will be common in everywhere. So what I can cancel? I can cancel. Now what I can get? G I can take common. I can get sin theta minus mu s cos theta is nothing but this is the acceleration. So when one object in inclined plane, object there in inclined plane is sliding. It is sliding and friction is present. Then what is the acceleration? Now G sin theta minus mu s cos theta. Okay, or you can write here A equal to G into sin theta minus mu s cos theta. So remember, when friction is there, then there is the acceleration of object. So acceleration of object of block basically on inclined plane. On inclined plane with friction. Okay. That friction is there. Inclined plane with rough surface. Rough surface is there. This is the acceleration. Now suppose I star mark I'll write here for smooth surface. What the condition will come tell? For smooth surface, your mu s will be what? Tell. Smooth surface means no roughness, no friction. So for smooth surface, mu s equal to 0. If mu s 0, what is the acceleration tell? G sin theta. Okay, so that means what is this one? Now this is your, because mu s is 0, this term will become 0, already G sin theta only will be there. So this is the acceleration when object is sliding on inclined plane. So why on smooth surface? So here this is the basically, directly let me write acceleration of block on inclined plane, on smooth inclined plane. On smooth inclined plane. That means if your object is sliding, then this is the condition coming. So basically here object is sliding. Are you understanding the meaning of sliding? Sliding means moving, sliding and coming. Okay. So A equal to G sin theta for smooth surface. But rough surface na G sin theta, G bracket sin theta minus mu s cos theta. Okay. Or you can write also G sin theta minus mu s G cos theta. That also can be. Clear idea? No doubt here? Okay. Next one more point I'll tell, then after you can note it down. Just wait first. For smooth surface, rough surface, you understood the things. Are you getting or not here? All of you. One inclined plane is there. This theta is called the angle of inclination. And if a rough surface I am taking, if I am doing the free body diagram of a mass on the inclined plane, then I am getting y-axis, x-axis equation by applying Newton's second law. Then friction also mu s n, I am getting friction. Then after that is maximum static friction I am getting. Then I am substituting f in the equation 2, then I am getting here acceleration. Okay, if I will substitute for smooth surface mu s 0, then acceleration coming g sin theta. Clear idea? No doubt here? Okay. But now suppose smooth surface, if you are sliding case, this is the condition. Sliding or skidding. Skidding means slipping. Okay. Sliding. Now, suppose I will tell one condition I will consider. No sliding. Suppose no sliding or no skidding condition on the inclined plane. No sliding or no skidding. That time what will happen? Say, no sliding condition. Now tell, your acceleration will be what? If object is not moving, acceleration will be 0. Yes or no? If acceleration 0, what I can write? G sin theta minus mu s g cos theta will be equal to what? 0. That means I can write G sin theta equal to mu s what? G cos theta. Yes or no? Now G will cancel here, check. G and G will cancel. G and G cancels. Now if I want to write mu s, what I'll write? Tell, sin theta by cos theta equal to what? Mu s. That means tan theta equal to what? Mu s. So this is the condition when object is not moving. You can write here. So here block is not moving. Block is not moving. So when block is not moving, what is the condition coming? Now tan theta equal to mu s. No sliding condition or no skidding condition. Okay. This theta is called basically what? Angle of inclination, or sometimes you can tell angle of repose. What you can tell? Angle of repose. So this is the idea, you understood what is condition coming. No sliding condition, no skidding condition, no motion. Okay. So A equal to 0. Tan theta equal to this much, mu s. Okay. Or you can write mu s equal to tan theta. Mu s equal to tan theta. This is what you would remember about this inclined plane. Okay. Up to this one you should understand. I hope you got the point. Yes or no? So now from the beginning you write the note and remember, if a object is accelerating or object is sliding on a rough inclined surface, this is the acceleration. If that surface is smooth, then this is the acceleration. Clear? No doubt? Tan theta you got. If theta you want to find, what you will do? Here, if suppose I want to tell theta what will do? Tan inverse mu s. Tan inverse mu s. This is your theta. Okay. This one you can tell angle of inclination or angle of repose. Angle of repose you can. Okay. So this one you remember. Please note it down. Only 4 pages. Boys, no doubt, are you getting or not? Smooth inclined plane, rough inclined plane, if anything is there, acceleration you can find it out. Okay. Acceleration you can find it out. No doubt, right? Okay. Thank you. Like and subscribe Vidya Lakshmi NEET Academy YouTube channel. All the very best.